Hello and welcome. Today we're working on how to solve for payments in the time value of money calculation. Now the payments could be plus or minus, they could add to account or subtract from account. So let's get started. If you're new, my name is Jeff from Finally Learn. I teach a lot of accounting and financial topics, so please like, please subscribe, and please join us. All right, so here's what we have. We have payments. Now we're going to use payments, and these are sometimes called annuities or ordinary annuities. And here in this video, we're going to assume that all the payments happen at the end of the period. Now, if we assume the payments happen at the beginning, then that's called an annuity due, and we have to use a special little button, beginning and ending button, but this is an ordinary annuity. Check out the playlist for the video on ordinary annuities versus annuities due. All right, so here's what we have. We're going to have periods per year is our setting, and then we're going to plug in all four things: the number of periods, the annual interest rate, the present value, and the future value, and we'll solve for the payment. Now, sometimes one of these might be zero, and that's fine, but that is a variable. That's an input we want to put in. So I have three different examples, so let's get started here. Let's say you buy a car by signing a note for $26,000. The loan is for 6.5% for 5 years. So here's what we have. We have present value is $26,000. The loan is going to be for 6.5% and for 5 years. Now, this is not a 5-year problem. This is a 60-month problem, because what is our monthly payment? Now, one of the things we need to do is we need to show the future value is going to be zero. So we're going to pay off this loan of $26,000 at 6.5% for 60 months. And so here I've calculated with Excel $508.72. So let's show you how to do it on the calculator. So here's our inputs. Just converted the word problem to inputs. So one thing we need to do is we need to set up the periods per year is 12. Okay, so we'll do the second function, periods per year. It's 12, but if I had to change it, I would do 12, 1, 2, and then enter, and then clear out of that. So what is the number of periods? Well, the number of periods is 60. We'll put 60 in as in, and then 6.5, 6.5 is the interest rate. We can put 26,000. We can put that in as positive because we have borrowed money, so that is the present value. And we need to put in 0. Now, if 0's there, we need to enter 0. 0 is the future value, and so let's compute the payment. The payment is $508.7199, so it's 72 cents. So if we have a $26,000 loan at 6% for 5 years, our monthly payment is going to be $508.72. Now, this payment came out to be negative. You see that? Now, you don't have to say it's a negative payment, but you know that it's out of your pocket. You're going to pay the bank. You're going to pay the finance company $508.72. They never pay you. They say, by the way, hey, thanks for buying this car. We're going to pay you $500 a month. Then everybody would buy a car, right? The problem is we're paying to the bank $508.72. All right, let's look at the next type of investment. You have an account for $3,000. In fact, let me clear this out so we can kind of enter it together so you kind of think about the logic here. You have an account for $3,000, okay, so that's today. And you want to have $100,000 at the end. Okay? You want to have $100,000 end of 10 years. How much should you save each month if your account earns 9%? Well, this becomes a monthly problem. The periods per year is going to be monthly, right? So 12 is the periods per year. And you're tempted to put in 10 here as the number of periods. Well, that would make it 10 years. This is really months. So how many months do we have? Well, we're going to take 10 times 12, and we're going to get the number of periods is 120. And what is our interest rate? Well, our interest rate, if we can earn 9%, then what happens is our payment, we would say, look, if I already have $3,000 and I want to build it to $100,000, then I need to make a payment of $478.70 every month. And you're building that, and it'll reach $100,000 if you earned exactly 9%. Well, what if you earned 10%? It would be a little higher interest, but it'd be a little lower payment. So let's show you how to enter it on the calculator. We have an answer here we can point toward. Well, the second periods per year should be 12. If it's not 12, we enter 12 and then enter and clear out of that menu. Well, the number of periods. Well, on 10 years, it's easy to take 10 times 12 and get 120, but your calculator can do this. You can just enter 10 and then do second function, periods per year, or times the payments each year. So it'll take, because periods per year is 12, it'll take 10 times 12 and equal 120. So if you have an odd number like 9, well, what's 9 times 12? I don't know if I remember right offhand, but you can do that easily with your calculator. Your calculator will do this based on the periods per year. So we've got 120 periods, so I hit N, and then 9% is the interest rate, 3,000. Now, present value and future value are always the different sign. If you enter, let me just tell you, if you enter the 3,000 as positive and the 100,000 as positive, on your calculator, on the BA2 Plus, your error message is going to say error 5. I don't know why it's 5, but that's what it is, error 5. If you see that, then you know you need to enter one of them is negative. So we're going to say I'm paying out of pocket $3,000, that's the present value, and I'm receiving 100,000 future value. So we're going to compute CPT, the payment. So we need to pay out of our pocket $478.76. If you do that and you get exactly 9% every year compounded monthly, then you're going to have 100,000 at the end of 10 years. Okay, that's exciting. That gives you a goal and motivation. All right, the third example, same type of thing, except you have an account with 900,000 and you want the money to last for 15 years. So let me clear out all this and enter it all together. You want the money to last for 15 years. How much can you withdraw each month if your account earns 6%? Now here we're assuming the account goes to 0, so we're going to put future value as 0. We're going to put the present value as 900,000. 15 years, well, it's going to be a monthly. 15 years, what's 15 times 12? Well, we can do that on the calculator. 15 times 12 is going to be 180 months. What kind of interest? Well, 6% is the annual rate, but it's going to be a monthly, compounded monthly. So how do we enter this on the calculator? Now, because my previous problems have all been periods per year is 12, I don't have to do that, but I would do second function, periods per year, 12, enter. And then I need 180 months. Well, I can take 15 times the 12 and get 180, and that's the number of periods. 6% is the interest rate, 900,000. 900,000 is going to be the present value. Now, if I enter this as positive, my payment will come out negative. If I enter this as negative, the payment will come out positive. We can kind of ignore the sign here. So let's put present value in as 900,000, 0 as future value, and then compute the payment. We're able to take out of that account $7,594.71 if we want our money to last for 15 years. So if we took that out, now what's the total amount? Now you're earning interest along the way at 6%. If you take $7,500 times $180 over the 15 years, you would withdraw $1,367,000. So this 900,000 continues to grow even though we're withdrawing money every month. Now, this assumes you're going down to 0 at the end of 15 years, and hopefully you don't need any more money after 15 years. So that's the calculation. If you want the money to last 15 years, you would take out about $7,600 a month. All right, so this is how you do payments using your BA2 Plus financial calculator. I have a whole playlist on time value of money for Excel and time value of money for BA2 Plus. So thanks for watching. I've got a video right here that YouTube thinks you're really going to like.